Water is a necessity to human survival, but what are we to do when it gets polluted? One of the most famous cases of lead pollution that is still ongoing today is in Flint, Michigan. In Flint, lead pipes are the transport for drinking water, and the amounts of lead reach up to 300 parts per billion. To put this in perspective, 15 parts per billion is considered dangerous and undrinkable. Removing lead from water is not easy. Heavy metals cannot be strained or boiled out and require a complex and expensive chemical procedure that are unrealistic for those with polluted water to achieve. Our goal through this project was to find an inexpensive, do it yourself way to remove the lead content in drinking water. Consumption of lead is bad for your health, and especially bad in children. In severe cases, it can cause stroke, developmental delays, abdominal pain, learning difficulties, and many other symptoms.
After doing research, we found that banana and orange peels have the ability to remove lead from water. This is due to them containing acids that allow what's called chelation. Chelation is a type of chemical bond in which a molecule forms several bonds with a metal ion. The molecule is referred to as a chelating agent. An example of a chelating agent would be amino acids, which are found in quinoa and seaweed. Other sources include cilantro, cauliflower, and vitamin C. We decided to use fruit peels in particular because they are normally considered waste. Making use of them will allow for a cost-effective and environmentally friendly product.
Our experiment was making lead nitrate and running it through a filter that we designed and mixing a potassium iodide to see if it would turn yellow, which indicates if there's lead in it. The process was first dehydrating banana and orange peels to crush it into a powder and using it in a filter that we constructed using a coffee filter and two strainers. We did that 4 times, one controlled, one orange peel, one banana peel, one both orange and banana peels.
So after the experiment was carried out 3 times, we found out that once the water went through the orange peel filter, it did not really change color. The same thing happened for the banana peel filter as well, as the water didn't really differ from its the control variable that we had set out. But we did find out that after mixing the orange and banana peels together, letting them soak in the water for a little bit, and then running them through the filter, that the water did end up slightly differing in color, which leads us to believe that we have to definitely change up our experiment for next time and go into further detail with it a little bit more. We had many different sources of error throughout our experiment. Many of these were caused by the fact that we didn't have access to the facilities that were required. For example, we weren't able to get an accurate measurement of the lead content in water during the experiment, which really led us to focusing on qualitative measurements as opposed to quantitative measurements, which did not give us an accurate representation of whether our theory would work or not, which did set us back as well. During the experiment, we weren't really sure as to how to appropriately measure the lead content in water, which led us to a lot of experimenting. And through experimenting, we finally found a process that worked, which took away a lot of time as well that could have been used to further develop our experiment that we came up with right now, and really just expand on the theories that we had made up. We would also like to test out other fruit peels and vegetables to see if they would also have the same lead combating properties that banana peels and orange peels have. Just because in our research we did find out that vegetables such as cilantro and coconuts did have properties that could combat lead or that duplicate the properties such as banana peels and orange peels. So we want to see if there's more materials that we could use in order to make our filter more successful, and see if there's other at-home materials that people would have easy access to also clean out their dirty water. Once we are able to get access to a lab or to further equipment, we definitely want to see if there's a way we can expand our filter design to combating regular dirt and other pollutants in water in order to implement this design in third world countries, as our filter is made from very common items that are found at home, and stuff like banana peels and orange peels are usually thrown in the waste. So essentially we're using waste to recycle and create a safer environment for the rest of the population as well. In conclusion, our results were sort of inconclusive in the sense that they were qualitative and there was not really a way of effectively determining whether or not the lead content was reduced due to the fruit peels. But in theory, our hypothesis would be correct as orange peels and banana peels do have lead combating properties. As well, we have seen that we've seen clues that our hypothesis would be correct, as once we soaked the orange and banana peels together in the water, and then filtered it through the system, we evidently saw that the lead content was reduced. So this leads us to further believe that our process or our procedure of experimenting was a little misguided, and we would just have to change that up for next time.